first one has you review what we went over yesterday. And as I've already said, this is a very, very, very typical AP question. Not as in they give you tons of these, but I promise there's going to be one of these on the AP test this year. They give you a graph of a derivative. And as you're looking at it, they're asking which of these is true, must be true. Okay, concave downward. What is true where the graph is concave downward? Katrina, go ahead.
Second derivative, like, do that thing where it changes from.
Ooh, if the second derivative changes signs, that's a point of inflection. But you're good. You're right that we need the second derivative for concave downward, but we're wondering where the second derivative is negative. Concave downward? Negative, right? Second derivative is negative. So, how do we look at a second derivative on a first derivative graph? Do you remember from yesterday? Look at the slopes. You can say f double prime negative would be the slopes are negative. You could say slope downward. What's another way of saying slope downward? F prime is decreasing. It means the same thing. So either f is sloped downward or f prime is decreasing. It means the same thing. So question is, the graph sloped downward is f prime decreasing all the way from here to here. Increasing, decreasing, increasing. This little area right here, from 8 to 16, that would be concave downward for f, not f prime. And then it would also be concave downward from, technically, negative infinity to negative 8. But no, A is not right. B, increasing. What do we know about increasing? F is increasing when? F prime is positive. And if I have a graph of F prime, I say F prime is positive when F prime is above. Where is F prime above? Here, and all of here. So negative 8 to 8? Oh, no, he's below. No, that doesn't matter. He's above from negative infinity to negative 16, and he's literally above from 0 to infinity, but he's not above all the way from negative 8 to 8. Doesn't work. F has a local minimum at negative 8. What are they trying to trick you with in all of these? They're saying, look at F prime's minimum. F prime has a minimum of negative 8, but does F?
Yeah.
What does it take to have a minimum of F? F prime has to change from
Negative, positive, positive, negative.
negative to positive. 0 is a minimum, not negative 8. Not negative 8. And then the last one, F has a point of inflection at 16. Yes, why? F double prime changes from, the slopes are negative to positive. If the slopes go negative to positive, the second derivative changes from negative to positive. Or you could say F prime changes from decreasing to increasing. All of those are reasons to say, booyah. But A, B, and C were all based upon you guys looking at the graph wrong. Careful, careful, careful. Okay, number 92. Hold on, pause. How many of you guys got D? Okay, like 10? Okay, that's better than I expected. How many of you guys picked an answer because you were looking at the graph wrong? Our only courageous ones. The rest of you guys just didn't do anything, huh? Didn't pick an answer and didn't get the right one? That's interesting. Thanks, cool kids. Number 92. AKA not cool kids. 92. Were you supposed to take a derivative at all?
No.
Not for A or B, because what did they already give you? They already gave you the derivative. So therefore, for A and B both. Corey, you were mentioning this one. You were like, wait a minute, why didn't they say this one first and then that one? Either way, you were asking that because what do you have to make in order to do either of those?
Sign chart.
Sign chart, good. Sign chart of the first derivative. Kiddos, what numbers do we put in a sign chart of? Wait, pause. If you're not labeling this, I can almost guarantee at some point you're going to accidentally plug into the wrong thing. You need to put your little labels. Why? Because that reminds us who to plug into. I'll show you that in just a second. But first of all, who do we even put as tick marks?
Zeros.
Zero. Set that first derivative equal to 0. Does the 12 make a difference?
No.
Why? You would divide him to the other side. Poof, he's gone. The negative 12 doesn't make a difference. Divide him over, it's still 0. Now I set each one equal to 0. Does the squared really make a difference?
No.
No. So my two zeros are just? Why did I say label this? Because if you're going to do a sign, you can't do the sign of anyone but. You have to plug into the first derivative. What do you guys get as your signs? On the left of 2?
Positive.
Positive. On the in between 2 and 4?
Positive.
After?
Negative. That's it.
Okay, so then we have, it is a cool one, but positive, positive, negative, meaning f is increasing, increasing, then decreasing. Question, is there any relative extrema? Where?
4.
Why?
Because it goes up and then it
Wait,
goes down.
don't use it.
F increase.
First of all, f exists at 4. Remember, f exists at 4. If it was a dotted line, it wouldn't work. F exists at 4, and then,
F is
F prime is
increasing.
increasing.
f prime,
F is
F is increasing.
f is increasing, and then,
F is decreasing.
so f changes. Listen to my wording, because there are going to be FRQ things where you have to justify. F changes from increasing to decreasing at 4, or f prime changes from positive to negative. What's another reason to write these? So you know which characteristic goes with which. If you say f prime goes with increasing, guess what? You just missed the whole justification. You might have gotten the answer of 4 with relative max, but you just missed all the points that you could have gotten from this book. You can't mix your terminology, and you can't say it. Okay. So, relative max at done. Relative min, none. Letter B, where is f decreasing? Yeah, 4 to 50. I see that. Uh-oh, letter C. What's it ask? On what interval is the graph of f concave downward? Now, guys, could we kind of guess somewhere-ish here? Is it concave downward? We could probably guess that. It's a polynomial. But to get the exact, what are we going to have to do? Take a derivative. That negative 12 can just chill, right? He's a constant. What rule do I have to do? I have to do product. So I'm going to get second D first. Uh-oh, D first. How do I take the derivative of u squared? Down the 2, leave it the same, times u prime. Right? Plus, you have to have a plus. You have to have product rule. If you don't have a plus, you forgot your product rule. First, D second. Well, that's easy. That's just 1. Now, some of you would say, uh-oh, I better start foiling.
No, we can't.
How do you make it easier when you get to the practice test number 2? Oh man, you're going to want this. Pull out. Who's in common? Good. Then you have what left? Well, I have, let's see, that's going to pull out, right? And that's going to pull out. So that's going to be gone, and then one of those is going to be gone. So I have 2x minus 8. And then I have plus x minus 2. Nice. X, I have my second derivative, f double prime, x minus 2 times 2x plus 1x is 3x, negative 8 minus 2 is negative 10. You guys agree? Cool. So what are my pips? And why do I need those? Because I'm about to make a sign chart of my second derivative, and I need pips to plug in. Wait, 2/3 and 10. Wait, 2 and 10/3. 10/3 is 3 1/3. Okay, so 2 goes first. 10/3 goes second. When you guys plugged in signs, what'd you get? Uh-oh. Okay, then I'll help.
0 would be.
Negative, negative, negative. Is that a negative?
Yeah, that's a negative.
And then 3 is less than 10/3 and bigger than 2. 3 is positive, negative, negative, positive, right? Then 5,
Would be
negative.
positive.
Positive, positive times the negative on the outside, right?
Negative.
concave downward, negative infinity to 2, 10/3 to infinity. Dun, 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 dun. Points of inflection, yes or no?
Yes.
Where do you look? Which sign chart? Increasing, decreasing, or concavity? Concavity. You ask, are there any points at which the signs of the second derivative changes? Ooh. Or where the concavity of f changes? Yes. Where? And if there were little x's widthwise, how would you get those x's widthwise? Right now we just have x's. Oh, you need the original. We don't have them. Good thing I didn't actually make you do. All right, we good? Kiddos, with that, let's go ahead and grade. Those are AP practice. I think we got through all of our examples from section 3.5. That's a first. Yeah. All right, let's go ahead and grade 3.5 evens real fast. Remember, if you don't have it ready to go, you can grade it tonight after you finish the kiddos. We have other stuff to be doing. I've tried to get as many resources as possible to prepare us for a good test on Friday. We're taking today and tomorrow to work and to practice multiple choicey questions, AP-ish questions, etc. So you have to get caught up on this homework so we can review. All right, first one. I already did the derivatives for all of the initial, wait, were there any evens? Number 12 was an even, right?
Yeah.
Was there anything before that? Okay. Where can you find that derivative key? In our shared folder, where would you go? Handouts, assignments, then what? Keys, right? And then homework 21, just like I said it would, derivatives key. Does that show you all the first, second derivatives of the first 5? Yes. All right, here we go. Sorry. Oops, that's not what I want. There we go. Now, whew, good thing I don't make you do this. My 14 identifies isn't that bad after all, by the way. Okay, let's figure out what's going on, though. First of all, we have intercepts, right? We have x, y intercepts of 0, 0, and we have x intercepts of plus or minus 3 and 0. That's for number 12. You have critical numbers. Oh my goodness, screen. Killing me. Oh, this is just a mess. You have a relative min at -3 over rad 2. You have a point of inflection at 0, 0. You have a relative max at 3 over rad 2 and 9/2. Those are your points. And then you have all of your increasing, decreasing, concave up, concave down, no asymptotes, horizontal, vertical, oblique, or otherwise. And domain is just between -3 and 3. You end up with swoop, swoop, swoop. Which you guys technically, wait a minute, if you know the original function, couldn't you check it in your calculators anyway? Oh. And really quickly, in case you got a little stuck, the critical number, 3 over rad 2, is the same thing as square root of 9 over 2. Simplified. But you guys already don't know the derivatives to check. Next even. 38. Okay. Hey, were you allowed to use your graphing calculator?
Yeah.
Nice. Which meant that you could have found the relative maximum and minimum using your cool little feature, right? How did you find your point of inflection? Who should you have graphed? You could have either graphed f prime and found his relative mins or maxes, or you could have graphed f double prime and found his zeros. Let me do a quick illustration of what I mean. Now some of you are like, ugh, but you had to find derivatives. I know. But how else are you going to look at this? How else are you going to get that answer? You have to use your calculator. And as we saw yesterday, in that menu, there is no option, no function for points of inflection. So you're going to have to take derivatives, but you get to use your calculator after that. So it's up to you. You could either, dun 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 dun, dun 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 dun. Come on. Thank you. You could either throw in your first derivative. Thank you. And find the maxes and mins, and I'll illustrate that really quickly. And I won't do all of them. I'll just do, how many points of inflection are there? 2? I'll just do one of them. So we could do our x to the power of, that doesn't work. Come on. Oh, for the good old days when I was able to use a real calculator. X to the 4th.
Plus 2x squared
Thanks. Keep going, Brandon. I'm listening.
minus 8x
Keep going.
minus 1
All over.
all over
Plus
parentheses
plus one.
x
Plus
squared
one.
plus 1
Plus 1. Okay, all over who?
parentheses x squared plus 1 squared.
Like that?
Yes.
Okay, I'm just going to do Zoom Standard for sake of
It'll be that.
simplicity. Is there going to be, oh, look, it's a max. Look, it's a min. Guess what? Where the slopes of f prime change, what are you going to have? Points of inflection. So I could have done, without having to take another derivative, which some of you are like, praise the Lord, who wants to take another derivative? But you could have just gone ahead and used your really spiffy max feature, number 4. You could have gone a little bit before, boop, and a little bit after, boop, 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 boop. And then guess who you would have found?
Yeah, got it.
Point of inflection number 1. Point of inflection number 1. Now, could we have graphed the second derivative? Yes, we could have, but you would have had to have found it, and some of you are like, yep, nope, don't like that idea. But we could have graphed the second derivative if we wanted to. And we could have gone ahead and, I'm on the wrong feature, and I'm just going to do that really quickly and get a fraction. Could have done our 8 times 3x squared minus 1 all over x squared plus 1 cubed. But this time, with a second derivative graph, which you guys had a couple of second derivative graphs in homework, I think, or at least one. When you go to graph the second derivative, I'm looking for zeros or DNEs where the sign changes. What? How do you, zeros or DNEs where the sign changes. And real quick, did I plug it in right? 8 times 3x squared minus 1 all over x squared plus 1 quantity cubed. Okay. If I was to zoom in just a little bit, I'm just going to solve for it real quickly. I want the 0 of the second derivative where the sign changes, hence where it goes from, it meaning the second derivative, goes from above to below. I want the 0 where it goes from above to below. Hey, I found it. Yay! Wait a minute. Where do you get this number from?
You plug it in.
You take your x and plug it into the original. So remember, you can use your calculator, but if you decide to do the zeros of the second derivative where the second derivative changes sign, changes from above to below, you just have to find 2 derivatives. If you use the first derivative, you can just find mins and maxes and save some time. Question, any more evens? No? Really? I gave you all ones you could check, huh?
80.
Oh, 80? 66 and then 80? Okay. 66, letter A. B, C, and D. Is this the one where they gave you the graph of F? No, this isn't.
Oh, yeah. It made it harder than it is.
F is increasing from -4 to 2 and -2 to 1. For A, for letter B, concave upward on -2 to 0. Letter C, there's your 2 increasing. There's your 1 decreasing. But that was just explanation for why they're saying there's a relative max at 1 and no relative min. And then letter D, F double prime is 0 at, these are your pips. And they say that the sign changes of F double prime at both of those, so they're both actual inflection points as well. As just a couple of you are still checking, my ones are looking at the problem that you wrote down for homework because you're amazing in right directions and problems and don't want to miss points. What did they give you in 66? A graph of? F prime. So if you missed some of these, maybe today's warm-up helped a little bit, yeah? Maybe today's warm-up helped a little bit. We're working on the graph of F prime. It takes time to reorient our brains. Okay, any other evens? 80, right? As you guys are checking the answers, real quick, those of you that wrote it down, who are you given in this one?
Here you are, fine graph.
F prime again? F. So if you're given an F, you're literally looking at F itself. And to figure out where f prime is 0, you're looking at where the tangent lines are flat. When you're looking at where f is decreasing or increasing, you're looking at the intervals where literally your graph of f is going up or down. When you're looking for when the second derivative is 0, you're looking at the points of inflection, which are the points where the graph changes from like concave down to concave up to concave down. That's where you find your zeros of your second derivative. This one gets a little tricky unless you remember our forever card that says when f double prime is positive, f prime is increasing and f is concave upward. So really you can just steal the same interval as concave upward for f because that's the same place that f prime is increasing. And then last but not least, letter D, f prime is minimum. Now that's weird. The slope is most negative. That'll be the minimum, most negative. It'll be lowest or most negative at the point of inflection 0. Letter D was a weird one. Happens at 0, and if you want to write yourself a little note, the reason it's at 0 is because the slope is most negative. Any other evens, guys? Huh?
No, I think that's
Okay. Tomorrow, at the beginning of class, we might go over homework questions, but some of you, frankly, as I can tell from what you are not doing right now, aka checking your homework, some of you need to finish tonight. Yeah? So we'll go over any questions you have remaining. You can check them online, because I just went through all the evens. We can come tomorrow with questions that you have, get some people to the boards right away. You guys did have 2 different multiple choicey ones, but let's save those just in case you have questions on them for tomorrow as well, because you might have questions on why 89 is what he is and why 91 is. We'll probably start by talking that through really quickly. Those of you that didn't have homework done by today, oh my goodness, you better by tomorrow. We're just going to go through just a couple. Oh, it's chapel day. It's a Wednesday, it throws me off. What do I want to do? Let's not do these. These are great AP questions, but frankly, that's not a lot like what you have. Instead, take one, pass around. You guys have out your practice test, right? Okay. You're going to take one, pass around, but grab out your practice test. Let me open your practice test as well. Go ahead, kiddo. I just need to be working while you're talking. Go ahead. I'm listening. Okay, go fast. If anybody was gone yesterday and doesn't have a practice test that we passed around yesterday, go ahead and go pick one up from the front, the AP Calculus AB tray. All right. Basically, for the next 8 minutes of class, and for pretty much all of tomorrow's class. Anybody who doesn't have one, raise your hand. The back of it. You guys just put it on my desk. Once you get it, Sarah, you'll probably get the last of them. For the next 7 minutes of class, and then for pretty much all of tomorrow's class, we're working. Working on what? Reviewing. How? Practice tests, chapter review problems. Although chapter review problems, to be honest, I'll probably kind of leave those for outside of class unless someone has a question on when we don't get tomorrow. Because you guys have CalcChat on the chapter review, right? So, right now, you are getting an FRQ that has something to do with the graph of f prime. Let me see if I can open that real quick. There he is. You are getting an FRQ that has something to do with f prime. But for right now, let's go ahead and table him. We'll probably come back to this FRQ tomorrow. You guys have a copy. Just keep him with your practice test, okay? But for right now, why don't we just go ahead and spend the next 7 minutes working on the practice test. If you guys have any questions, feel free to collaborate in your groups. But I'm also right here for anyone that has any quick homework questions from last night specifically, or you've been working on the practice test and you're stuck anywhere. You may collaborate in your groups if you would like. That's totally fine as well. favorite points of inflection coming from pitchfork books. Okay, this is the conclusion that MBT says after being accepted by the beings of single plugins that to find that out. Then you have to find F prime. Plug in, now remember you can either plug in C for X or you can just leave X and solve for this special X and Z. Nice thing on this practice test, guys, is it goes all the way back to Rolle's mean value theorem while also reviewing the more recent stuff. So you multiply them together. Question on number 2, did anybody check for discontinuities? Guess what this whole thing can be reduced down to be? There's a hole at -4. -4 goes in evenly. So we can actually divide and not have to worry about that huge nasty derivative. I don't know how to get rid of the shading. Anyway. So on number 2, if I were you, set the whole thing equal to x squared plus 4x plus 3, technically such that x cannot equal -4. Huh? Yeah, so it doesn't really matter anyway. Why should you show your work for the local?
Should we show our work for the local division?
It's up to you. You can go ahead and just say that, but I put a little parenthesis and say long division. That's all I did. Just say long division. That might help quite a few of you that are like, you gotta be kidding. It goes in evenly, so it's a lot easier than it looks. And then, absolute extrema, just because it's been a while. Absolute extrema. Going from -4 to 1. We can still do a sign chart, but ultimately, if you need to review this one, this is in section 3.1. We end up going to a table where we say, hey, take all of your critical numbers and take all of your pips, plug them in and test them. -4 doesn't really work, but when you take the derivative and set equal to 0, you end up with -2. We're going to plug in -2, plug in -1, and look at our little sign chart and try to figure out what's the highest he goes and what's the lowest he goes. Between a table and between... I wanted to help you really quickly on number 2 because he's an oldie. He's an oldie but a goodie, but he's a little tricky. And it gets a lot easier as soon as you use long division. Kiddos, I see people that are getting answers. That's good. That's good. That means that you're working on the practice test, okay? We're going to go ahead and write down all the answers for the practice test tomorrow. So the most you can attempt, the better. Cool? Work on that practice test tonight. Some of you need to finish up 3-5, and then tomorrow we're working, we're practicing, but please, during lunch after school, if you have extra questions, we want a good test on Friday. Get out of here. Chapel day.
And we're all. Yes, I Bro, I was gonna stay quiet, you know?
Don't forget extra credit, Steve. Unless you want to find more, just because you want to get this.
Instead of doing all the job this week.
Ricky, how many can you get out? Ricky, how many can you get out?
And then Jason, remember to put it in the middle of the folder if you're turning it in, okay? Thank you, bud.
You got it. You got it.
You know, ready for a better challenge? It's
Get
considered a genius.
Not be able to do anything.
My mom.
Bye, kid. I'll see you later.